Welcome back to the Deep Dive. We're the show that really tries to cut through all that noise, that cascade of information you get every day.
Right.
And we bring you the insights that really matter from the latest research, the newest analyses.
Our job is basically to give you that shortcut.
Exactly. So you can be genuinely well-informed. We always try to dig up those surprising facts, maybe add just enough humor, to keep you listening.
Keeps it interesting.
Today, we're tackling a huge topic. I mean, it feels vast, almost overwhelming for a lot of people, doesn't it?
It really does.
But it's undeniably central to, well, everyone's future. The planet's critical turning point.
Mm-hmm.
You see the headlines constantly, you hear the stats, and it could just feel like this jumble of anxiety.
A lot of noise, yeah.
But that's what this deep dive is for. We're going to cut through that. We've gone through a whole stack of recent scientific reports, some really compelling analyses.
And the idea is to lay it out clearly.
Yeah, a structured journey. Our goal isn't just telling you what's happening with the climate.
No, it's deeper than that.
It's about really understanding why it matters to you right now and what the absolute best science tells us about the path forward. And it is clear.
It is. And it's not abstract theory, is it? Not some distant future thing.
Not at all. It's concrete. It's immediate. It's already affecting our daily lives, global stability, the economy.
Even our mental health, as the studies show.
Absolutely.
Yep.
So we'll pull out the core insights, the facts that might surprise you, and really the urgent implications from all this material. You should walk away really knowing what's what.
And what really jumps out from the sources we looked at for this dive, it's the sheer volume, first of all, but also the consistency. The scientific consensus is just unwavering.
It's not just a few studies here and there.
No, not at all. These reports give a comprehensive, really undeniable look at where climate science stands right now. They focus meticulously on the key indicators.
The things we can measure.
Exactly. And their cascading effects right across the planet. And the data, well, it paints a very clear picture of rapid measurable change.
Rapid being the key word there.
Rapid and accelerating. It reveals this profound sense of urgency, and it's all backed by hard data.
Okay. So to really get a handle on that urgency, where do we start?
We need to begin with a concept that's crucial, but actually surprisingly tangible when you break it down. It's the idea of a global carbon budget.
Like a bank account for the planet's emissions.
Pretty much, yeah. It's the planet's ledger for CO2, and frankly, it's telling us a very, very stark story right now.
Okay, a planetary budget. So how do we even begin to grapple with something that huge? The sources seem to point to a very specific starting point, don't they? This carbon countdown.
That's the term scientists are using, and it fits. It's not just a number, it's like a deadline.
A planetary deadline. A stark, immediate challenge. It gives us a limit, right? A quantifiable limit on CO2 emissions.
Precisely. If we want to stay within that really critical 1.5 degrees Celsius warming threshold.
So, the bank account analogy. We're close to being overdrawn.
Perilously close. There's very little left to spend, so to speak, before we hit a point where some significant parts of our climate system might not recover.
Okay, so let's get specific. The sources mention a major study, right? Over 60 leading climate scientists involved.
Yes, published in Earth System Science data. It represents the absolute cutting edge of climate modeling and projection right now.
And what does it say? What's left in the account?
It's startlingly small. The remaining carbon budget, just to limit warming to 1.5 degrees C, is only 130 billion tons of Kuro.
130 billion tons. Starting from when?
Starting from the beginning of 2025. That's the total amount we can still emit globally if we want a reasonable shot at staying below 1.5.
And what's a reasonable shot in this context?
That 130 billion figure gives us roughly a 50% chance. Flip of a coin, basically.
50%. That doesn't sound great. Is there a safer estimate?
Well, if you want higher certainty, say a 66% chance, 2/3 probability of staying below 1.5 degrees, then the budget shrinks dramatically, almost unbelievably, down to just 80 billion tons.
80. From 130 down to 80? Wow.
It really underscores the risks we're taking with every single ton of carbon we continue to release.
So, okay, let's translate those numbers, 130 billion, 80 billion tons into time, because those numbers sound huge on their own.
They do, but the context is everything. Our current global emission rates are, alarmingly, around 40 billion tons of co-euros every year.
40 billion a year. Okay, do the math.
Right, that 130 billion ton budget, the 50% chance won. At current rates, it could be completely gone in around 3 years.
3 years.
And if we aim for that safer, 66% chance, budget the 80 billion tons.
That's just 2 years.
Just 2 years.
Wow, that's not some distant problem for our grandkids. That's I know.
It's an immediate fleeting time constraint. It means we don't just need to shift away from fossil fuels, we need to do it with unprecedented speed.
A pace of change we've literally never seen before.
Exactly. The clock isn't ticking in decades anymore. It feels like minutes.
Okay, so the budget is tiny, the time is incredibly short. What happens when we go over budget? Why is that 1.5 degree number so critical?
That's where translating the numbers into consequences becomes absolutely vital, and the sources are really explicit about this. Passing 1.5 degrees isn't just symbolic. It's not just another number on a graph.
It's a real shift.
It represents a profound, potentially irreversible shift in the Earth's stability. Think of it less like a gentle slope and more like walking towards a cliff edge.
Okay.
Every fraction of a degree above that 1.5 limit dramatically increases the likelihood and the severity of impacts.
Like what specifically?
More extreme weather events, much more intense and frequent heat waves, accelerating sea level rise, pervasive ecosystem collapse.
And it's not just a little bit worse, is it? It's not linear.
That's a crucial point. It's often nonlinear. 1.6 degrees isn't just slightly worse than 1.5. It can trigger cascading effects, interconnected changes. It can push us past planetary boundaries where the whole system starts behaving unpredictably.
And there's something else the sources mentioned, this idea of a lag.
Yes, the lagged response of the climate system. This really underscores the urgency. It means even if we hit that carbon budget limit, or even if we magically stopped all emissions tomorrow.
Warming doesn't just stop on a dime.
Exactly. The system has inertia, like a huge supertanker, right? It keeps it moving for miles, even after you cut the engine.
So the warming that's already baked in, or continuing from past emissions,
means some future impacts are already unavoidable no matter what we do right now.
That's a really sobering thought. The full effects aren't instant.
No, warming continues for a while after the emissions happen, which is why acting now is so critical to prevent even more severe warming down the line.
So pulling all that together, the tiny budget, the short time frame, the nonlinear risks, the lag effect, what's the bottom line from the sources?
The bottom line is stark. These figures aren't just jargon, they are, as the sources put it, a stark countdown.
A countdown.
With only 2 to 3 years of budget left at current rates to meet our goals, rapid decarbonization isn't just an option anymore. It's the only viable path forward if we want to avoid the most catastrophic outcomes.
And what does rapid decarbonization actually entail?
It means a systemic, urgent shift. Across everything. It means definitively ending our reliance on fossil fuels, aggressively expanding renewables at a scale we've never seen.
Protecting forests.
Absolutely. Actively protecting and restoring forests, which soak up carbon, and significantly improving how we use land to cut emissions and boost sequestration.
So these actions are basically our last chance.
The sources conclude they represent our final, critical chance to avoid the most severe, irreversible climate outcomes. Outcomes that would fundamentally reshape human civilization as we know it.
And the thing is, we don't actually have to wait for that countdown to hit 0 to see the effects, do we?
Not at all.
We're already seeing these intensifying impacts right now. These heat waves, the extreme weather, it's rewriting the rule book.
Yeah, the examples are becoming commonplace, frighteningly so.
The sources give some really stark ones, like that heat wave in southeast England back in 2022, 32 degrees Celsius. It basically brought things to a standstill.
I remember that.
Well, the science now says that specific event was made 100 times more likely because of human-caused climate change.
100 times? That's staggering. It's not just bad luck.
No, it's a fundamental shift in probability. And that's just one example, right?
Globally, it's intensifying incredibly fast.
The sources say last year alone, 4 billion people, think about that, over half the planet, experienced at least 30 days of record-breaking temperature.
4 billion.
It's not just uncomfortable, it's dangerous. Every fraction of a degree warmer increases the danger. More heat waves, yes, but also
more intense floods, uncontrollable wildfires, devastating huge areas, destructive storm surges, changing coastlines.
These are the immediate effects. They're already reshaping our world, impacting lives, livelihoods, the landscape itself.
And connecting that to the bigger picture. These events have profound, multifaceted impacts on health, on society, on critical ecosystems. The sources detail this meticulously.
Let's talk health first. That seems incredibly acute.
It is. That UK heatwave in 2022, It tragically led to nearly 3,000 excess deaths. It's a stark reminder that heat is a silent killer.
And globally.
Globally, extreme heat now ranks among the deadliest natural hazards. It's responsible for up to 500,000 deaths every year.
500,000. Wow. And that's not just heat stroke, is it?
No, it exacerbates existing conditions, cardiovascular problems, respiratory diseases. It strains emergency services. It fundamentally compromises public well-being. It's a truly sobering statistic.
And these impacts aren't felt equally, are they?
Not at all. That's a critical point. Vulnerable populations always bear the brunt.
Who are we talking about specifically?
The elderly, low-income communities, people with pre-existing health conditions, outdoor workers, they face significantly higher risks.
There was that example from Pakistan and India in 2022.
Yes, a devastating heat wave. Attribution science found it was 30 times more likely due to climate change. It resulted in over 90 recorded deaths. But the suffering, the economic disruption, it was immeasurable.
So it highlights this huge social equity issue.
Absolutely. Those with the fewest resources, who contributed least to the problem, often suffer the most.
And beyond health, there's the strain on infrastructure, the economy.
Huge strain. Heat waves cause massive spikes in energy demand. Everyone turns on the AC, right? Grids get strained, sometimes to breaking point.
And farming.
Critical crop yields are threatened. Sources suggest potential losses of up to 30% for some staple crops. That hits food security, agricultural economies hard.
The healthcare systems must get overwhelmed too.
Totally strained. Dealing with surges in heat-related illnesses pushes them beyond capacity, and then you have urban heat islands.
Right. Cities getting much hotter than the surrounding areas.
Exactly. Concrete, asphalt, lack of green space. They trap heat. It makes it even worse for the dense populations living there. It's a dangerous feedback loop. It all adds up to massive financial and societal costs.
You know, for years, it felt like the conversation was always a bit vague. Like, well, climate change might be making things worse.
Yeah, there was uncertainty.
But the sources point to a scientific breakthrough that's completely changed that. And this is where it gets really interesting, even revolutionary.
Attribution science.
Exactly. This idea that we can now link specific extreme weather events directly to human-caused warming. It's not guesswork anymore.
It's measurable.
Yeah.
Scientifically rigorous.
And it allows researchers to draw these incredibly precise connections. This changes everything, doesn't it?
It really does. And what's fascinating is how it works. And the sheer amount of evidence it's already produced. Big studies, like the ones in PNAS you mentioned, they showed definitively that over 80% of the globe has already seen increased frequency or severity of heat extremes and dryness directly because of human-caused warming.
80%. So the human fingerprint is literally all over our weather now.
It's a measurable change in the climate's fabric. We're not just talking general trends anymore. Attribution science gives us specifics on individual events.
Like those examples. Argentina, South Asia, Nigeria.
Right. Heat waves in Argentina in 2022, South Asia 2022, Nigeria 2023. Scientists have analyzed them rigorously, found they were dozens, sometimes hundreds of times more likely because of our emissions.
Hundreds of times. That's not vague correlation. That's
And powerful, precise causation, quantifying exactly how much we've amplified these events.
And if we connect that to the bigger picture, what does knowing this allow us to do?
It's incredibly empowering. Understanding these precise trends, using high-res data and these studies, it allows for really focused adaptation and mitigation policies.
So instead of guessing, we know where the risks are amplified.
Exactly. We can prioritize things like urban cooling strategies, better early warning systems for heat waves, social safety nets for the most vulnerable, accelerating clean energy. We can do it all with much greater precision because we understand the specific risks climate change is dialing up and where.
Okay, so moving beyond the immediate shock of extreme weather, climate change is hitting us at an even more fundamental level, isn't it? Food and water.
The absolute basics for survival.
And these are becoming foundational crises. They threaten the stability of whole societies, could lead to widespread suffering, even conflict.
The potential is definitely there.
The sources highlight one statistic that really stopped me. A huge study, 54 countries.
Yes, that's a significant piece of research.
It found that for every single degree Celsius increase in average global temperature,
Yeah.
there's a drop in essential calorie production of 120 kilocalories per person.
Per day.
120 calories, gone. For every person, every day, for every degree. That's huge. It's enough to significantly impact global nutrition, food security, and it's not just a problem for developing nations or subsistence farmers.
No, absolutely not. Even high-income countries, big agricultural producers like the U.S.
What about the U.S.?
They stand to see corn yields a critical staple crop drop by a quarter by 2100.
A quarter? That's a massive hit to the global food supply chain.
It is. And then there's the water issue. It's this dangerous dual challenge.
How so?
Changing rainfall patterns mean we get both prolonged, devastating droughts in some areas.
And paradoxically, worse floods in others.
Exactly. So it simultaneously escalates water scarcity, harder to grow food, harder to get drinking water, and causes immense water damage displacement. It's a double-edged sword.
Hitting our basic ability to feed and hydrate everyone.
Fundamentally challenging it.
Let's unpack those findings on crop yields a bit more. That nature study you mentioned.
Right. Covering 12,600 regions across those 54 countries. It confirms that 120 calorie per person per day drop for each degree Celsius.
And
Crucially, that figure holds true even with farmer adaptation efforts factored in.
So it's not like, farmers will just adapt and it'll be fine.
No, this is the reality even with our current best efforts. And looking ahead, mid-century projections under moderate warming.
What do they show for staple crops?
Corn, wheat, soybeans, declines of up to 25% in the U.S., similar, potentially steeper, reductions worldwide. It's a direct, undeniable threat to global food security. Could lead to widespread malnutrition, hunger.
And then the water scarcity issue. Agriculture uses a massive amount of water, doesn't it?
Huge amount. Globally, about 70% of all freshwater use is for agriculture. In some lower-income countries, it's up to 90%.
90%.
So when climate change messes with water availability through erratic rain, longer droughts, changes in snowpack and glacier melt,
which are critical water sources for many.
Absolutely. When that gets disrupted, it doesn't just affect drinking water. It fundamentally disrupts the very foundation of our food system. And this is happening on a vast, accelerating scale. Water is becoming an increasingly vital and contested resource.
And what about the combined impact? Heat and water stressed together.
Yeah, a major 2024 study looked at that. It projects global agriculture could lose between 6 and 14% of its output by 2050 just from that combined stress.
6 to 14% globally. Are there specific country examples?
Yes, the sources give some stark ones, showing the regional differences. India could see declines up to 16%, China potentially 22%, the U.S. around 12%.
Those are huge numbers. What does that kind of productivity shock mean for people?
It means dire consequences rippling through societies. It could increase the number of people facing acute food insecurity by anywhere between 556 million and potentially 1.36 billion people.
Over 1 billion people potentially pushed into hunger. That's almost unimaginable.
It's an immense potential humanitarian crisis, fueling social unrest, mass migration.
And we're already seeing these crises emerging, aren't we? It's not hypothetical.
No, it's happening now. The sources give vivid examples.
Like Nigeria.
Nigeria declared a food security emergency recently. Decades of drought, erratic rain, it crippled their water-dependent agriculture, pushed an estimated 31 million people into acute food insecurity. And food prices
doubled. Food price inflation literally doubled, making basic food unaffordable for millions.
And in Europe. We think of Europe as being relatively stable, but
Europe saw its driest spring in a century in 2023. Widespread drought risk, severe economic losses over 28 billion euros, especially hitting cereals, livestock.
So these aren't just isolated incidents anymore.
No, they're becoming more frequent, more widespread, more severe. It shows how fast climate impacts can destabilize entire regions, disrupt economies, create emergencies. It's a fundamental challenge to global stability.
So how do these foundational issues, food and water, how do they intertwine and make things even worse?
Well, they compound each other. Water shortages obviously impede access to safe drinking water, which, as the sources note, 2 billion people already lack.
2 billion right now.
And it also cripples irrigation, which we need for agriculture to feed billions. Over half the world's croplands already face high water stress. It's a current daily reality for a huge part of humanity. Just surviving is a struggle.
And the economic hit. Alarming. Affects everyone. The Global Commission, cited in the sources, predicts up to an 8% loss in global GDP by 2050 if we stay on the current path. Over half of global food production is at risk just from water stress.
So it's not just about food and water in isolation, it's about systems breaking down.
Exactly. Climate change is undermining both, yes, but it's also exacerbating existing vulnerabilities, pushing economic and social systems towards breakdown. The interplay of heat, water stress, falling yields, it threatens livelihoods, fuels migration, poses a serious threat to global stability.
So the message is clear. Act now or these trends continue.
Absolutely. Without immediate systemic action, things like drought-resistant crops, massive water efficiency improvements, irrigation reform, and fundamentally drastic emissions cuts, these trends are set to continue, potentially heightening hunger, displacement, crisis worldwide. It's an existential challenge for many and a major geopolitical concern for all.
Okay, let's shift gears slightly. Beyond the statistics on food and water, there are these incredibly visible proofs of change. Things we can literally see happening. Melting ice, bleaching reefs.
Undeniable visual
They're not just numbers in a report. They're striking, observable